Hello guys, I'm going to try to solve this exercise. It's the first of the list that I've given to you I've posted on lesson. It's a sample question from the chapter that deals with radioactivity, the first chapter in our last unit. Okay, consider the following nuclear reaction. And the first question is, what do you mean by nuclear reaction? This is comes straight from the definition of a nuclear reaction. It's the spontaneous transformation of one element into another with the emission of certain particles and or radiation into another. So you see, let's take a look over here. Aluminum was transformed into phosphorus. Okay, one element has changed into another. All right? This is the first question. The second, who discovered the phenomenon of radioactivity? The answer is either Henri Becquerel or Marie Curie. It's up to you. Choose either one. The third question, what is the nature of the above reaction? Now it's either natural or provoked or artificial. Provoked or artificial or stimulated. Either one of those would do. And the reason is there's an external factor. That external factor, if you take a look over here, I'm going to erase those. Aluminum, not all by itself, has changed into phosphorus. We had to bombard it by this external factor, alpha. Okay, if you don't know what the external factor is, do not implicate yourself over here and just write the external. There is the presence of an external factor provoked it. Okay, stating the laws used determine A and Z. I'm going to erase those again. A and Z. Well, the laws would be, so what these laws? Law of conservation of mass. Law of conservation of mass. Mass before equals to mass after. If you take a look at the mass before was 27 and 4, 30 and A. Those are the masses before. 27 and 4 equals to 30 plus A. So that would give you an A, which is 1. And the second law is law of conservation of charge number. And that would, the charge number is, I'm going to erase this again. Those at the bottom, 13 and 2, 15 and Z. 13 plus 2 equals to 15 plus Z. So that would give you a Z, which is 0. Okay, remember those two are called Soddy's laws. Soddy's law. Proceeding to the fifth question, identify X. Well, we obtained X to be 1, 0. And this is nothing but a neutron. Okay, we have to write it down. This is a neutron. You should have memorized this, or just take a look at this. It's neutral. The sixth, what is the nature and characteristics of this X? The nature, it's a particle by nature, and its charge is neutral, it's heavy, and it has a low penetrating power, and it has a speed of around 40,000 kilometers per second. It could be more, it could be less, but this is basically it. Okay. Now, number 7, define the half-life of a radioactive element. And the half-life is, once again, this is pure definition. The half-life is, it should be the time. Anything that doesn't start with the time, it's wrong. It's the time taken by radioactive element to lose or to decay half, again, of its initial mass. Alright, those are the keywords I'd be searching for. It's the time taken to lose, to decay half of whatever you initially had. Alright? 8. If the mass disintegrated out of a 32 gram sample of aluminum is 30 grams after 60 days, So we start with 32 grams, and after 60 days, we end up losing 30 grams. Can you find the period of aluminum? So once again, I had 32 grams and I've lost 30 grams. So the mass left is the initial mass, which is 32 grams, minus mass lost, which in this case, I've said it's 30. So I need to stop where I have 2 grams left. So starting with 32 grams, and in one half-life, I end up having half of whatever I initially had, and that would be 16 grams. Another half-life, I'd end up having 8 grams. Another half-life, I end up having 4 grams. Another half-life, I end up having 2 grams. So I stop at 2, because the mass left should be 2. And I said all of this takes place in 60 days. So 1, 2, 3, 4 half-lives are worth 60 days. So one half-life is worth 15 days. Okay? Number 9, calculate the mass left after 25 days out of a 10-gram sample of the same aluminum. Now, we can go by the formula that says the mass left is the initial mass over 2 power n. The initial mass is 10 grams over 2 power t over t. 10 grams over 2 power t, the total time I need, it's 25 days. One half-life is worth 15. And the answer would be, I'll pause that a bit, the answer would be 3.14 grams. This is the mass left. Okay, remember we could have solved this by a different manner, just plotting a graph of whatever we have over here. We started initially with 10 grams. This is the mass and this is the axis of time. Okay, at 0 we started with 10 grams. After one half-life, which is 15 days, we end up having half, 5. After another half-life, 30, we end up having 2.5. After another half-life, 45, we end up having 1.25. Okay, and if I were to plot this, it would look something as such. So I need, what is the mass left after 25 days? It's somewhere over here. If you go that way, and you would find the answer over here to be approximately 3.14 grams. You have to plot it up to scale in order to make it accurate. Alright, now we proceed to number 10, and the rest are supposed to be easy. Define the activity of a radio element. The activity is the number of atoms disintegrated per second. That is the activity. It's once again a course question. The number of atoms emitted per second. They have to be per second. And the activity is measured in becquerel. Now the 11th question. Calculate the activity of aluminum if 24,000 atoms are emitted during 10 minutes. I'm sorry, this is long, so we have to scroll up and down. The activity is the number of atoms over the time taken. The number of atoms is 24,000 atoms over the time taken. It's 10 minutes. So that would be 4, 0 and 0, 0 and 0, and that would be 40 becquerel. This is way low in activity. And then 12th question would be, the preceding reactions are often accompanied by the emissions of gamma rays. What is the nature of those gamma rays? I'm going to answer them over here. What is the nature of gamma rays? They are electromagnetic rays, electromagnetic radiation. Are they more penetrating or less penetrating? All those are course questions. They are way more penetrating than alpha. When are those gamma rays emitted? Once again, that's a course question. Whenever we have the de-excitation of an atom, or whenever an electron jumps from a high energy level to a lower energy level. All right, hope that does it. And you proceed and follow this model to figure out the rest of the questions. And I will be posting the rest of the solutions to those problems later on.